Hey guys, this is going to be the second day of section 7.1. It was just better to do the notes on here so that I had less to try to write on the whiteboard. So I'm going to go ahead and share my screen and we're going to get started. So here we go. Starting broadcast. Sweet. So if I take a look here, we are going to do these notes, and this is going to be somewhat of a review from yesterday, just this first one, but I wanted to kind of put out something there. So we found a lot of displacement and total distance yesterday, right? But we didn't say something like end of the trip, right? So here it just has a little graph, and you can assume that this is a velocity graph. And basically it moves it forward and then it moves backwards and it stops moving forward. But if we want to find the distance in this velocity graph, we just got to find the areas, right? What's the area of this little segment? What's the area of this little segment, etc.? Well, it's just 1 times 1, which is 1. But this one would be -1, right? That would be positive. +1, -1. So if we want to find the location of the particle at the end of the trip, this is actually another way to say displacement. It's just that you have to keep in mind what initially happens here, right? So if it's originally at 3, so it'd be kind of like if it's on the XY axis, right? And if it's originally at 3, this is saying that it's going to go forward 1. It's going to go over at 4, but then it's going to go back to 3. Then it's going to go forward again, and it's going to go backward because it's going 1 space over, back 1 space. So where's it going to end at the end of the trip? Well, it's just going to end at 3. And the reason is because the displacement is actually 0 on that one. Find the total distance though. What's the total distance that it traveled if it went back and forth twice? Well, its distance is total distance is 4. So that's that. Moving on. This is really interesting, and I always every year have to double check the book, and it's because I still have a typo, which I need to fix when I get back to school. This is miles per hour per second is what this should say. So that's really confusing. And the reason that they do that is so that we're going to be able to integrate it nice and easily. But essentially, what we got going on here. Sorry, I had to take a drink here. We have acceleration. We did not do a lot with acceleration yesterday, but I did mention that if you go backwards, right, from acceleration, you're going to get velocity, right? And then backwards from velocity, we know is position. So if I want to go backwards from acceleration, I'm going to get velocity is. Now the reason it says miles per hour per second, acceleration is usually like meters per second squared, right? In physics, you always do have a time squared. But the nice thing is if they said hour per second, that means at the end of 8 seconds, that's going to relate to this. That means we can just go backwards and plug in 8 seconds. So if we go backwards, we're going to get 1.2 t, which is going to be miles per hour. But then also, no, 1.2 t squared, my apologies, plus c. But they do give us an initial velocity of 5 miles per hour. So this is really interesting because velocity is still miles per hour. But the time we can plug in is 8 seconds because the acceleration was miles per hour per second. So they kind of just set this problem up correctly for you unit-wise. Do be aware that I know the units are confusing, but as long as you understand that you go backwards from acceleration to get to velocity and backwards from velocity to get to position, you're going to be just fine. So here, let me erase that. If I need to find c, I plug in 0 for t, right? And 5 for v, and I'm going to get c equals 5. So my equation, finally, is v of t equals 1.2 t squared plus 5. And then I can just plug 8 in right there. And do 1.2 times 8 squared plus 5. And I will go ahead and plug that in my calculator. But while I'm plugging that in, go ahead and take a look at the next one if you would like. So 1.2 plus 5. So that's 81.8 miles per hour. Velocity is still being measured in miles per hour right now. Now it says how far did the car travel during those 8 seconds? Well, how far would be position, right? And how do we get to position? Well, we just take another antiderivative, right? So what is that? T cubed, 0.4, right? 1.2 divided by 3 plus 5t plus c would equal position. Now in this case, though, we're just saying how far did the car travel. We're just going to say that c is 0, right? Because we're just saying it hasn't started anywhere at this point. We just want to know those 8 seconds. So we'd plug in 0 and 0, and we get that c equals 0 anyway. So we'll just get rid of that. Now this is where we do have to be careful. Since the velocity was in miles per hour, right? This is going to give us miles, but only if we plug in hours, right? Up here, we were able to plug in seconds because their units were miles per hour per second. So what we're going to go ahead and do is we're going to plug in, instead of plugging in 8, we need to do 8 divided by 60 will give us minutes, right? So it's like 0.133 minutes. But if we divide it by 60 again, I'm just going to divide it by 3600. It's like 0.0022, that gets 2 repeating. So that's what I'm going to plug in. I'll just do 0.0022 cubed plus 5 times 0.0022. So let's see what we get, and that'll be how many miles this thing traveled in that amount of time, in 8 seconds. So let's see here. 0.4 times 0.0022 to the third plus 5 times 0.0022. I get 0.011 miles. Provided I did that right, which I think I did. What is that in feet? Let's just take that times 5,280. It's 58 feet. 58 feet in 8 seconds. That's not bad. That's just more out of your curiosity. But the main thing I wanted you guys to get out of that page is going backwards from acceleration gets you velocity, and backwards from velocity gets you position. In my opinion, I guess I don't think you guys can decide what my opinion counts for. We, with this stuff and thing we did yesterday, have really covered the most important part of this section. A lot of the rest of the section is some weird word problems, and what you need to know is that a lot of times these word problems are going to give you rate of something, and then you need to figure out basically a total. But that's kind of like velocity is a rate, and then when you figure out how many of something was consumed or something, that's going to be like a total. It's going to be a displacement or a total distance or something. Now, what's nice is a lot of real world examples don't go into the negatives. So remember, when we don't go into negatives, total distance and displacement are the same thing. So really what you need to know is, like, this is a crazy word problem, but as soon as I see rate of potato consumption is this, I'm going to think to myself, I probably am going to have to integrate that to get a total of whatever they want, because it says how many bushels were consumed from the beginning of 1972 to the end of 1973. So if they say the beginning of 1972 to the end of 1973, pretty much the end of 1973 is the start of 1974, right? So they're saying they want 2 whole years there. Now, what 2 whole years? This is where you just have to be careful, because you're actually going to plug this in. You can plug this into int if you want. We can do it by hand, but I'm okay to just plug it into int. So here's our function, right? And then what are we plugging in? We're going to plug in from 2 to 4, because it's going to be the start of 1972 to the end of 1974 or 1973, which is the beginning of 1974. So we need these 2 years. But what 2 years are they? They're that. And the reason we use 2 to 4 is because it says that it begins in 1970, right? I wonder if I can do this on Desmos. Let's find out. I don't know. It will indeed let you start typing int. It just pops up for you. I love that. So from 2 to 4 of 2.2 plus 1.1 to the, oh man, I forgot my plus sign. This is very nice that we can do this on Desmos, though. I like this. Everyone take note. Hopefully it actually evaluates it, but I guess we'll find out. Maybe it won't evaluate it, and dang. it's not evaluating it. I'm probably typing something in wrong. Who knows? Dang. Well, I'll go back over to my computer really quick and put it in there. But you guys have probably already minted it by this time. Does everybody remember where the mint button is in your calculator? Press the math button. It's like math 9 or something like that. So let me see what we get when we do this. We get 7.1, and you'd put millions of bushels, not billions, millions of bushels. There we go. I'm going to save the craziest problem for last. So I'm about to jump past one that I'll come back to. But here is one where you're going to do almost the same thing. Like you see here, it says a pump connected to a generator operates at a rate depending on how much power is being drawn from the generator. The rate was recorded at 5-minute intervals for 1 hour. How many gallons were pumped during that hour? So again, if you see a rate, right? So here we say at a rate, depending on how much power is being drawn. And so since it depends on how much power, there's not a function here, but they give us an XY chart. We've seen XY charts a lot. We could potentially like make a line of best fit or a cubic of best fit or something, which sometimes is what people do. The other way to do this is if it's at 5-minute intervals, things like maybe RRAM or LRAM, MRAM kind of sucks, so let's not do that. Or trapezoid rule or something. All of those things can come back, which is great for the AP test to kind of see some of these things. This is a reason why it's still worth going over some of these things. So, I mean, if we wanted to use RRAM, we'd have to do something like, oh, how far are all the times apart? All the times are 5 minutes apart. So that's the number that goes out front, right? And then you remember with RRAM and LRAM, you just add things together. With RRAM, we'd skip the first one, so that'd be on the left side. And then we just do 60 plus 65 plus 64 plus dot, 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 all of those plus 63 plus 63, right? That's what that would be. If we want to do LRAM, it'd be the same thing, right? But you just wouldn't use that 63. So I don't think I'm going to focus on that one. But there's one in the book that wants you specifically to use trapezoidal rule. So trapezoidal rule, remember, is that take that number of how far these are apart. It's h over 2, right? That's your h. And then trapezoid rule is when you do like, you use all of the numbers, right? You got to take all the middle ones times 2. So you do 58 plus 2 times 60 plus 2 times 65 plus 2 times etc. plus dot, 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 plus 2 times 63 plus 63 without a 2. And I'm not going to bother plugging those in. I think we will be fine without that. So basically, there's just a lot of ways to find integrals, and a lot of, whenever you see a rate, you should think we got to go backwards to get something. AP people, probably going to be a question, even though this AP test is shorter, there's probably going to be a question that has some random function. And it might be an XY chart, it might just be an equation, but it's gonna be a rate, and you're gonna ask to find how many of, like one time it's like how many cars go through an intersection. If here's the rate at which you see cars enter the intersection, like, and you just have to integrate it from the time period that they say. So, all right, and this one really is kind of ridiculous. So here we go, this is where we're gonna end today. And this is really a bogus example. There's one like this in the book. It is just good to see that sometimes that they phrase things this way, but this problem is, in my opinion, one of those ones that's like, really, why are we doing this? Here's what it says. Population density measures the number of people per square mile inhabiting a given living area. Washington, population density, which decreases as you move away from the city center, can be approximated by this function at a distance r miles from the city center. So basically, that ends up being like a circle, because they're saying if there's a center of a city, right? And as you go out from it, like if we went out a mile, we'd plug 1 in for r, and 2 minus 1 would be 1. And so 10,000 times 1 is 10,000. So that means right out here in this area, there's like 10,000 people per square mile. That's insane. That's like really dense if you think about it. because Greenville has less than 10,000 people. And so they're saying like right at the city center, there'd be like 20,000 people per square mile. But here's what's crazy is if you look at the first question here, this is so unrealistic. If you look at the first question here, it says if the population density approaches 0 at the edge of the city, what is the city's radius? Well, I just plugged in 1. What number could you plug in and get 0 to your equation here? 2. So if you're at 2 miles out from the city center, then all of a sudden, like you're already at 0. So it's saying that this city that's 2 miles, you know, in radius is super, super dense at the middle, because whatever this area, you know, almost has 20,000 people in it, that square mile. And then by the time you get to the outside, you have none. So all I gotta say is if you have the coronavirus, you do not want to live in the middle of the city. But you'd only have a 2-mile walk to get out of the city. So there you go. So the city's radius is 2 miles. And it's because you plugged anything higher than 2 into your equation, you're going to get a negative number. So the city had ended. Now, the second question is also just like, what in the world? It says a thin ring around the center has a thickness dr and a radius r. So I'll just draw that. What they mean by ring is like this, right? I think that's why they call this thing Washington, as they're saying if you kept on drawing rings of, you know, different colors here, you know, you'd end up with like a bunch of washers. Anyway, long story short, they're saying, let's say that one of these things has a thickness of dr. So can't even squeeze that in there. So that's how thick it is. And then it's got a radius right there of r. They said, basically pretend that I cut it right here where I drew that slit and I stretched it out. They're saying if you stretch it out, it would look like this, which, I mean, that's believable. And they want to know what's the area of this strip. They are setting you up for the next two things, but this is very bizarre. So the area of this strip, well, we know the thickness is dr. This way is not r, the radius was r. This way is whatever the circumference is of that circle. What's the circumference of a circle? Circumference is 2 pi r. So the area of this circle is just those two things times each other, or this washer, not circle, because it's just this part. Like if I filled it in, I'm hopping back up to my picture over here. If I fill this in, they want to know what's the area of this strip. And they're saying approximate it by stretching it out like a rectangle. So the area is just base times height, so it's 2 pi r dr. Then it says, and here's why they set you up for this. It says, explain why the population of the ring above is this. So they're saying, what's the population of this? Well, population is always the density of population, right? So how many people live per square mile times the area, right? Because if you take, for instance, if 5 people live in per square mile and you take that and you have like 12 square miles you're looking at, then 5 times 12 would be 60 people would live there, right? So if you look though, that's exactly what this is. This part is the population density from the beginning of the question. And then the 2 pi r dr is the area from this thing. So since it's the density times the area, it's going to give the population. And then it says estimate the total population of Washington by setting up a definite integral. So definite integral means an integral with bounds, right? So it's actually saying if we wanted the total population, we could just plug in this 10,000, 2 minus r times 2 pi r dr, and our bounds would be from the city center, which is 0, out to the edge, which was 2. Now I haven't done this in a long time. I'm curious as to what that is. How many people live in the city? This is crazy. I do realize that that was a little nuts. So you may have to do the one that's like that on homework together. Here we go. I'm going to plug it in, and then we'll be done for the day. So 0 to 2. There's a lot to plug in though. 10,000. You guys probably already have it plugged in, but you're not live. Else I would just get your advice from you here. 2 pi, and then dx. All right, let's see what happens. Wow. Literally everyone would die from corona in the city. Saying there's 83,775, well, 6 if you round, but we'll go down, people who live here. That is nuts. Because the area of that thing is pi times 4. So that means there's like 12.6 square miles and 87 or 83,000 people, or 84,000 people. Yep, if you live there, I think you'd die of corona. So glad we live in Bond County and in Greenville. That's what I gotta say about that. So there you go. And that is the end of 7.1. So that's all I gotta say about that. And then we will have a Zoom for homework questions tomorrow. So we'll go over those and then we will get into the fun part of chapter 7. So thanks, fam. And we're calling it quits.